Over 11 years ago, I joined development for the streaming camera. Before that, I've always been on a backend side, a little bit of desktop development here and there, but this was my first experience into embedded. And I had mostly experience, well, my most pleasant experience was using Microsoft Visual Studio. A little bit of Vim here and there, GCC, Linux, Eclipse, and a few others, but Microsoft Visual Studio was my preferred choice. And obviously, since our design was based on Cypress FX3, we initially did use Cypress's toolchain and IDE, which I did not like, honestly. I wanted to move to a more modern platform, which is, to me, Microsoft Visual Studio. And this is the story of me moving from this Cypress Easy USB suite to start using my preferred tool, MSVC IDE. And this series of videos will explain in great details of how did I move from point A to point B. So initially, let's see, our initial stage is we are running Eclipse, which is a default IDE for developing Cypress FX3 projects. We will be running a sample UVC USB video class bulk. So UVC stands for USB video class, which is a sample provided by Cypress itself, and we will be basing our code migration on this sample project. And as you see, you can immediately see problems I was having with that. So out of the box, the way it is complaining about things it should not be complaining about. Like it says, I don't know what you inserted to T is, and it's giving me a whole bunch of other errors here and there. Like all the files essentially have errors. It only allows me basically two types of build configuration, debug and release, and also profile debug and release, but essentially debug and release. And honestly, since the device doesn't have a lot of resources, I'm more or less limited to release build because debug just does not fit. Moreover, how is the build done? There is some magic make file which sits somewhere, I'm not sure where. This is a make file, but it does use some pre-shipped something from the library, from the SDK itself, which sits in a different place, and then it chooses whether to use this include or the other include depending on your settings. So it's a bit of a magic. Not to mention the build itself. Let me kick it off. This, yeah, I have built it before, but the GCC that is running here, it is from 2013, I believe. So let me see, it's this one over here, which, okay, it finished building. So let me just verify ARM none EBI GCC, so just to run it and see which version that is. It does say 2013, so it's obviously somewhat outdated. We are in a year end of 2024, so that's more than 11 years old at this point. It does have some login being done to UART. If I can quickly find it somewhere around here, like not this one, but oh, here, CYUS U3P debug print with some magic number 4. Essentially, it does output into UART plain text. It's just that, plain text, so it's green on black. If you set it up, it's a terminal which doesn't have ANSI colors. And the USB descriptors, let me take a look at this file over here. So essentially it's a bunch of numbers with comments on that. And it's readable, I'll give you that. But if you want to change anything, for example, if you were to add a new support for a new frame rate, it's a bunch of numbers of unknown origin, and then you need to update a whole bunch of other numbers which basically tell you inside your USB descriptor where other parts live, how to get to them, what is the offset, what are the sizes, and if you get one of them wrong, your whole descriptor is being thrown out and Windows says, I don't understand your USB device. So you need to be very precise. It is not easy to not forget something. So this hand rolled out USB descriptor section, I hated it with passion. Especially, as I said, it is okay when you need to read it, but when you want to modify it, it's a major pain in all the parts of your body. On top of that, the build reproducibility, since you would only have these few files in your GitHub repository or any other source control, you are at the mercy of more or less third-party SDK. Yes, you can say it's been built with version such and such, and in my case I was building with Cypress FX3 version 1.3.4, and when I downloaded a new one for this video series, it was 1.3.5, which is different. How different? I did not check. I did not actually read much into release notes. There was not much information of what is the difference between 4 and 5. I can assume there were some bug fixes, I can assume there were some changes, but I have no idea. So if I were to have a product already in a field and I wanted to port a bug fix to it, I would need to be very explicit about where do I get which version of SDK, and it's not guaranteed that the version I get from the web some years later is the same one I got initially. So I really prefer to have that stuff in my source control with everything else. So it is one bulk of everything that is needed for my build that I can rely on being reproducible later on, even years later, especially when I need to keep working on that. Or if I need to share it with other teammates which may be joining team at different times, they would be downloading newer versions and we would be out of sync, and that results in a whole bunch of fun nights spent on debugging issues which are not even there. And speaking of development and sharing with the team, I really prefer to be able to just set up the environment, all the important things, and then share the environment with the team. Lately, people I see do it using Docker style containers. I'm not sure. I'm not a big fan of Docker, honestly. I see the positive uses of it, but I'm an old, okay, call me old fart, but I do prefer to have control over things, which is probably one of the reasons I'm more of a Windows or Linux guy and not much of a Mac. Apple, I do want, the first time I download and install a program, I always go into settings and I check everything out, because, well, that's just the way it is. So having said that, this is the initial state, and what the final goal is to be able to use like modern Microsoft Visual Studio, not Visual Code, Visual Studio. There are some crucial differences between the two, but since I am also doing desktop development and driver development, I really do want to have all the tools under a single umbrella, so I don't need to retrain my internal context switch. I don't need to move from one type of environment to another when I move from one project to another. I'd like to have as little change as possible from A to B. And what we have in here is, well, first of all, we do have a fully self-contained repository that has all the things we need. So let me just quickly get into there and just show that in here, for example, right? I do have SDK as part of my checked in code. I do have the tools that came with SDK also for that particular version of SDK. I do have my code, I have all the dependencies, unit tests, it's all in my source control. So whenever I need to get back to a particular version to rebuild it or to take a look at it or to compare, I can always go back and compare things. So that gives me, my external dependencies are part of my source code. It gives me reproducibility, and on top of that I also do have the ability to just set up my environment the same way if I move to a different box or I share it with a teammate, because I can save my environment settings for the IDE itself. And on top of that, what I can do with Microsoft Visual Studio is I can even save the configuration as in what to install. So all the components that I needed for successful run, they are part of the install configuration, and whenever a new team member joins, I just tell them, here is the file, install using that file, and you'll be up and running the moment you finish downloading and installing, which is extremely convenient, of course. With Microsoft Visual Studio, so again, comparing to what we have in Eclipse, I'm not as familiar with Eclipse, but how do I know where is this symbol being used? Where is my right click, and can I find references? Okay, project, I don't know, what does it do? It finds, it cannot be true, right? It cannot be true that it's only been used in one place in define, so something's wrong here. In contrast, if we are working with properly set up Visual Studio, I have all the navigation. I can do, like, let's find all the references for some random code right here, and it's searching through my project, it's giving me colorization, it gives me all the necessary, like unit AT, for example. It's I can navigate, it shows me which file it opens for that. I do have, well, we'll get to that, but I do have a whole bunch of release types which are particular to how my UART login is being done. And since I'm on C++, not C, I am able to completely even turn off login. For example, in my release build, all the login has been compiled out, no macros being used. There is a make file which is no magic, it's roll hand rolled. I would have used CMake, except CMake today does not have support for C++ modules, and I do use modules, so for now at least I am stuck with a hardcore make file, which I don't have much problem with. Once it's been set up, once it's fine. The tasks, what I can do from here, here's my right click menu, I can do the build, I can do rebuild, clean, I can deploy my code to RAM, to SpyFlash, I can switch it to the Cypress bootloader mode, I can even click on individual file and build it, rebuild, I can do unit testing, run unit test. So all that is specified in these files. Again, as I was saying, colorization, I do have access to full support of IntelliSense. I can do code navigation, there is a syntax highlighting, there is on-the-fly code analysis which would tell me if something is wrong, if something doesn't look right. There is symbol references, as I've shown. I can do refactoring, I can, there is right click with option like change signature, move definition, location, all that wonderful useful stuff. There is a code context, I don't remember, well, for example, the auto, let me find the auto function that returns the auto, like this one, right? It gives me what kind of variable it returns, which I can turn on and off if necessary, or I can just roll my mouse over it, will tell me the signature. So it gives me data types for variables, for functions, it gives me my comments specified for the file. So as I said, the full IntelliSense support. Also, on top of that, as I said, I moved to use C++. Currently, it's using LLVM, which is shipped with Microsoft Visual Studio, which is C++ 20 compatible. Depending on your preference, you can also use GCC if you want to. It does support modules. It gives me full access to constexpr, consteval, constinit. Again, greatly reducing size. For example, let's just be very explicit. My verbose mode, which does a whole bunch of UART login. Its size is 179K. But if I were to switch to critical, which is basically just the most critical errors and nothing beyond that, the size will go down significantly. And this is all mostly because my login function over here, it does evaluate constexpr whether UART at this level is enabled or not. And if it is not available, compiler just gets rid of it altogether, which significantly reduces the size because all those strings are no longer part of my binary. And obviously, as anyone who ever worked with embedded, you would know that size is everything, and the smaller your size is, the more functionality you can cram into the same kind of a device. So let's see, it's about to finish building, and it's 161, which is what, 19 kilobytes smaller. And we can go even further down into release mode, which essentially, so this one just compiles out whatever pieces of functionality are not needed, but the support itself is still being compiled in. However, in release mode, it goes one step further. It just says this whether we are using UART login or not, and if we are not using that, again, I'll go into all that in greater details at later videos, but this constexpr enabled would tell the compiler that no, this is not even being used, so don't even bother, and get rid of that. And that, I believe, saves me another 2 or 3 kilobytes of space. It's about to get finished. So the other one was 161, I believe, and this one is 156. So it's another 5K of code that I don't need to drag with myself into the release build. Another nice things about using a modern IDE is there is a support for Clang format, Clang tidy, with the newest C++, well, reasonably newest. I can use static assert style compile time tests. There is integrated Git support. To me personally, MSVC, I've used it for so many years. I am very comfortable with shortcuts, and I did not want to rely on shortcuts for Eclipse. I'm sure one could argue that you can set up Eclipse with shortcuts. I didn't want to do setup. I just wanted to have it work as is. And last but not least is the dark theme. I mean, this bright white, it hurts my eyes. I don't know how people use it day in and day out. I can use it for a very short time at a time, and it just kills me. And in here, what we have is a nicely looking dark scheme. And just to expand a little bit on that, the UART login. So the initial UART login, as I said, it was just black and white more or less. And then here, let me switch to verbose because I do want to show how it looks like when it runs. So that little window over there you see, let me just switch to that window. What it gives me is, as you see, a very nice view of things. I can immediately, with my bare eyes, see what I'm interested in. It's all color coded. I can see that if it's red on a dark blue, it would be some critical error. There are some error messages, debug messages. There is tracing that I implemented that basically tells me which function was called from where and the depth of the function call. On top of that, there is some maintenance of the stack, because I really don't want to run out of stack space, and I need to understand what my stack looks like. So there is a periodic health monitor, so to speak, which tells me that I've used in this thread that much stack, in this thread that much stack, so I can adjust if necessary. I can log my USB communications. In fact, again, we will get to that in a later video, but this particular build also supports WINUSB, which allows me to access the USB device from web browsers, for example, in a native format, which is a big difference because I don't need to develop native applications anymore. I can just develop a single web application that runs from a browser and gets access to all that. So this is mostly the final stage. What at the end of these videos, what we're gonna be looking at is this kind of setup. And one last thing about that is, on top of the setup, I will be talking about the custom framework code that I developed, which, as I hinted already, there is a tracing profiling with stack depth monitoring and health reporting. There is a specialized printf, because it turns out that the standard library printf, mostly because it deals with heap memory, and it's very versatile. It's a behemoth. It's just huge in size. I didn't want it to be that big. There is, as I mentioned, UART login with ANSI terminal colors. There are various build profiles that give me a fine-tuned size control over how big my build is. We will be talking about my rolled USB, UVC, UAC stack, which has USB descriptors, which are actually defined just like C++ classes. If I could quickly here, descriptor, there we go. So you don't need to have magic offsets, magic sizes anymore. It just gets baked in as you go, and especially when you start talking about like supporting video modes. For example, this one is video mode of this size. This is the default frame rate, and these are the other frame rates supported by that. So no more hand rolling and counting all those bytes and putting bytes in the right place for multi-byte, like 4-byte values. It's all being done at compile time, pre-built and baked into binary. There is also somewhat advanced I2C support, which allows me to easily use 8-bit or 16-bit or 32-bit bus with 8, 16, 32-bit data with, which are all kind of different slightly from each other, but underneath they look very similar. So templatized approach from C++ does a great job. There are some background tasks that are also, since it's a streaming camera, we do need things like auto white balance, focus, adjustments to brightness, exposure, those kinds of things, and all that has been taken care of on the background. And of course error handling and reporting, because here is the thing, USB device, it's not easy to debug, mostly because USB protocol is very strict about how long could it take for a response. And anytime as a human you're very slow compared to a computer, every time you try to break into a debugger on your USB device, Windows essentially will immediately time out and say, oh, I lost the device, you don't have the device anymore, go make some coffee. Because of that, I am more or less forced into printf debugging. But when it comes to errors, especially early in the release cycle when the hardware is not fully fleshed out yet, it's not easy to tell what is wrong. So one of the ways to deal with that is to use LED to indicate which kind of error it is, and there is a whole section of the code which basically deals with how to represent errors in a manner that is readable and can be monitored before USB debugging is even done, before UART debugging is even possible, before UART reporting is possible. So this is it, and I will see you in next videos soon, I hope.